I like your optimism.
Yeah. All right. See you. All right. Wonderful. Moving along, our next talk is from probably a familiar face. It is Dr. Kate Compton, aka galaxykate. Oh, looking fantastic. Styling.
My shirt has cats on it.
Oh my goodness. I would normally have to yell about let's see the cats, but we can already see these ones, which is good. Dr. Kate Compton, longtime generative artist, inventor, programmer, the archetypical artificer. She wrote the first paper on procedural platform levels, generated the planets for Spore, created the language Tracery, and invented an early phone-based AR system. She currently works as an open source researcher developing the next direction for Tracery and creative chatbots. Her mission is to design artificial intelligence to augment human creativity and to create tools that brings AI into the hands of poets, artists, kids, and weirdos, which I think is so in line with what Roguelike Celebration is about. So cannot wait for you to share this talk with us.
Thank you. All right, yeah, so today I'm talking on making polite programming languages, how to design a generative language without a programming language degree. And if you like the slides for this, there are a lot of cat pictures in them.
We don't have slides yet.
Oh, haha, sharing screen is better than not sharing screen.
It is important to share the screen. We like sharing here.
I'm very caffeinated right now.
There we go. All right, there's a kitten. Take it away.
There's a kitten. There is a tiny URL. I'd also like to call it a thanks for CROSS, which is the Center for Research in Open Source Software, which funded me for the last year and a half on the stuff that I will be presenting today, or the second half of the stuff I'll be presenting today. The first half will be about programming languages in general. So as mentioned before, yeah, I'm Kate Compton. I'm at galaxykate. I made the planets on Spore. You can see one of my unreleased planets there, the Magritte pipe planet. I also made Tracery.js, which runs a bunch of Twitter bots and also a bunch of random stuff at this conference, including apparently the drink maker in the amazing conference space. I do a lot of outreach for AI and creative computing. So if this were a normal conference, I would have like a ton of zines and a bunch of stickers, and I would be like shoving stickers at people. And I recently got my PhD from UC Santa Cruz. And then actually the bio that I gave Alexi is slightly out of date. As of earlier this month or earlier last month, I'm now an assistant professor of instruction at Northwestern University, where I'm going to teach a lot of students how to make weird generative things, and they're not going to know that that's weird. So I think there's a couple of them in the audience. So hi. So yeah, and then there's my website and my GitHub if you want to poke around in those. So kind of my specialty is, I've been thinking about this a lot, and like, I have a motto. I think everybody should have a motto, and I've workshopped mine a lot, and it's bringing AI to the people that AI doesn't deserve, which is very important to me. Like I've iterated on that a lot. And one of the things about it is I'm not bringing people to AI. I'm not demanding that people come and like learn AI. There's a book called Unlocking the Clubhouse, which is all about how computer science has often locked people out. That suggests that the right thing to do is to unlock the clubhouse and bring everybody into the clubhouse. But a lot of people are actually perfectly happy where they are. And so I'm trying to progress the takeout model of AI and computer science, where people come to AI and computer science, grab what they want, and then go back to their daily lives. And then people that AI doesn't deserve, I just think that people are awesome, and AI is sometimes a bit of a trash field. And so, yeah, really trying to do that work. But my specialty, it seems like, is figuring out the 95% of the fun that you can do with only 5% of the required knowledge. Knowledge is fractal. There's just too much of it to learn. And so if you can get a lot of fun without actually like taking 7 years of a PhD, then that's pretty good. So I've given lots of talks on things like, you know, how to do practical low effort PCG. Was at the Roguelike Celebration 4 years ago, which is like, you know, how do you do a lot of the setup stuff without trying too hard? And practical procedural generation, like how do you do AAA style procedural content generation without working as hard as we did at Spore? Things like I did a talk on Muppets and ballroom dance, and I know this much about Muppets and that much about ballroom dance, but I still turned that into a talk. And then recently, as of Thursday, I gave a talk, which I'm actually quite proud of, about sociology and how like hanging out online is making us become more creative together. So my talk really today is like to try to get you to 95% of the fun of programming languages with only 5% of the required knowledge. So making languages is an expressive exercise. This is really interesting. So these are a bunch of super weird programming languages that people have come up with. There's like, if you just Google like, what are the weirdest programming languages, there are lots of sort of stunt programming languages. So like, there's like this Doge speak one or cat speak one. There's like one that is programmed entirely in colored pixels. There's one that's just different amounts of the word chicken. And then there's things like, if you want to really see somebody at the top of their game in these sort of stunt languages, Martin Kleppe, if I'm pronouncing that correctly, gave a really fantastic talk at JSConf Iceland a couple of years ago. Those things that looked like kind of cool obelisks are in fact symmetrical programs, and he talks about how he made symmetrical programs. But you can also think of like, there are a lot of languages that you've been exposed to, and like, why would you write more programming languages? Like, yeah, okay, well, we've got like Java and JavaScript and C and C# and C++, and like, you write a for loop and it kind of looks the same in all of them. There's like a couple of different variants and maybe some Pythonic expression, but like, does the world really need another for loop? And the nice thing about programming languages is not all of them have to even have for loops. Languages don't have to all be trying to do the same thing. So over on the right is an example of a program. And you can argue about whether or not this is a program. The gist of this talk is that this is a program. And this is in fact a program for, like, I can't quite read this, but I think this is a program for some amount of like Sims hacking. Because it turns out that The Sims had a bunch of their UI and a bunch of their AI was stored in external files or files that you could get access to. And so even from The Sims 1, people were able to take these programs, which they were, hack them, edit the programs, and then re-upload them to The Sims where you could have different stuff. So this got a lot of people like sort of hacking tiny little programlets, which was great because otherwise it's like, especially back in like 2000, it was very difficult to edit a program on the fly. So domain-specific language making, and I guess the point there is that like, yeah, you can do languages to make for loops, but you can also just make a language that like expresses how Sims objects work. Like the Sims language object had a whole thing about like what it was advertising versus what it would provide. So like, there was a cigarette table that somebody made that would advertise to you that it would make you less lonely, but then it didn't actually make you less lonely. And so people would go and like go just like smoke forever at the cigarette table. But domain-specific language making is kind of addictive. So I've made or am making like Tracery, Tracery 2, Chancery, which is fairly well developed, and Greenery, which is mostly just like a glimmer in my eye at the moment, and some like speculative syntax stuff. But all of these languages are really just a way to kind of think deeply about a subject. So when I'm working on Greenery, I'm thinking deeply about what it is that an idle game is, and like what words I need to represent. Like what are kind of the unit operations of an idle game or a roguelike that like I can't express obviously in like Python? Like what are the things that should be like first-class words in my language? Of course, these are all under construction because every time I get close to finishing a language, I start a new language. So you may already be writing a programming language. If you are one of the people in the audience who is making roguelikes, you've probably written some of the following things, such as save files, config files, asset scripts, templates. If a computer uses a file to control program flow, that file is a programming language. So if you've come up with your own weird save file format, you have constructed a programming language. It might be a very special purpose programming language that only represents things in your weird game. Like this is a programming language that like has first-class functions for like the number of eggs that you have, or like certain macros that make certain things easier. But like that programming language is a meditation on what your game needs and what your game is about. So you've decided to make a programming language, or you've realized that you're making one. What do we do now? So the thing that a sensible person would do would be to ask a trained programming languages person. I've tried this. They're really nice people. They mostly talk to other programming language experts. And so when you say, hey, I'm working on a programming language, what should I do? they will info dump on you with a lot of terms that like don't actually represent the hard thing that you're dealing with. And so this talk is really a dilettante teaches dilettantes about programming languages. It's actually fairly hard to find non-ableist words for people who honestly have a lot of other stuff going on right now, but still want to talk about programming languages. Like, you just don't have time for a degree. You're perfectly able to understand this stuff, you just don't have time for that. So welcome to Dr. Galaxykate's 5-minute very wrong programming languages certificate course. So by the end of this, you will have your own very own certificate. So what's in a language? So a couple of things that are in a language. Like what is a programming language? If I say like JavaScript, what is that? So there are things like programs. So you have programs in this language. It's some code, although we can talk about what code is. And we all know what code looks like. It looks like that. Except that a lot of times it looks like this. This is some JavaScript from the newest Tracery. But it can also look like this. This is actually a Tracery program, or what we would call a grammar. So this is a program. It is not what's called a Turing-complete program for a Turing-complete programming language, but it controls the computer in some way. So it's a program. And more specifically, it's a kind of program that controls how things are expanded, which is what I want a Tracery to do. Here's a program. This is the HTML for the Roguelike Celebration. HTML is also a program. It is technically Turing-complete, but honestly, nobody cares. But it is still a programming language. Like, I would normally ask you to raise your hand if you recognize this. This is Stardew Valley configuration files. So this is how you get custom content in your Stardew Valley. And these are, in fact, ways of toggling switches on and off to load or unload content. So these are also programs. And sometimes they can be XML, they can be JSON, or they can be like custom, like weird text formats, or they can even be binary code. So there are things like Alan Kay's Grail, which I totally misspelled his name, Max MSP, Twine. These are also programs. They don't look like text. These are what are called graphical programming languages or visual programming languages. These have been going on since Grail in, I believe, 1968. But you can write programs in these weird formats. You may have also played with Scratch. So Scratch is another visual programming language. Unfortunately, when you go to save these things, some of them, I don't know what they're saved in. Some of them you can't download from the original program. Some of them, if you download the file and open it, so if you download your Scratch program, you can download your Scratch program, but then if you open it, it looks like the thing in the back, where it's just kind of like meaningless garble. So a parser is another one. So a parser is basically a way of taking this program. So you've written your program, whether that's Tracery grammar or whether it's JavaScript or whatever, and it's going to chop that up and turn it into basically like a tree of structure. So this is very similar to like having a token or like having a sentence diagram. And yeah, like you often have to deal with trees of nested syntax. So like the lower line there, x plus f, hashtag test foo. That's like a very nested Tracery syntax that I'm currently dealing with, having to like parse that and turn that into a tree. And it's like an expression with a string inside, which contains some hashtag syntax for Tracery, which contains, in fact, another expression. There's also things like compilers and transpilers and interpreters. These turn your parse tree into something else. What else? We don't know. It might be another language, or it might just be something digestible or runnable by like a lower level system. You might have seen things like, oh, you can run all these new programs in your web browser now. How does that work? Well, there's something called mscripten, which takes a lot of these older programs and translates them into what is now JavaScript, so you can run the JavaScript in your browser. So these are like, I forget whether that's a compiler, transpiler, or something else entirely, but this is kind of the same process. Like, we're taking some code and we're digesting it. And then engine, you need to actually do the thing. So, you know, Flash players and engine, Unreal and Unity both have engines. And then like, if you have a web page, each major browser has possibly a couple of different engines that it uses for rendering things. So V8 is what Chrome uses to render JavaScript, and it's considered very good. You'll also have an IDE, which often isn't considered as part of the language, but this is where people actually write a program. This gets really interesting because you can have things like processing where people are writing the program in the same place that they run the program. So this is, in fact, an IDE and an engine all together. And often IDEs have a bunch of like cool functions. So they have things like, they have linting, which is like checking for your errors dynamically. They have auto completion. They have code coloring. Modern IDEs may even have like things that you can like use to, if you rename a variable, it'll go through all of your code and like rename the variables out, or more. So there are a bunch of other cool things that IDEs do that we don't often notice. Things like social sharing. So I've been teaching Kat Manning actually coding on Glitch, and we're having a lot of fun together. But this is an IDE where we can both be editing the same code at the same time, and then we can also like share that code and like look at other people's codes. This is an IDE that is also a social network. Speaking of which, GitHub is an IDE, fight me. So there's also things like specifications, which tell you what a language is actually made out of. So a common language that we all deal a lot with is the Unicode standard. So this is a specification of like what emoji are there and how do we construct new emoji out of old emoji. And there's some great talks about like how do you get a dumpling emoji into this process? Like how do you find the room of the guys on the right and then tell them like, yes, we need a dumpling emoji. And then tools. You can host tools anywhere. They might be code, they might not be code, they might be tutorials, you can export code to them, you can import code from them. There are APIs, there are tool integrations. So the bottom right is a spreadsheet bot that I created on Artbot.Club. It loads a Google spreadsheet from a JSON endpoint, because you can create JSON endpoints with Google spreadsheets, and it slurps that up into my website, and then he parses it out and uses that to create a grammar. So yeah, here's the stuff that's in a language. And depending on your language, different parts of this might fall into different like parts of the, like might actually be different programs. So if we're talking about like HTML, okay. HTML I might edit in like, and my IDE might, just be a text editor. The specification is controlled by the W3C. And then my engine and my parser and my compiler are all in like Chrome. But there might also be other parts of this ecosystem. So, I might edit things in Dreamweaver, which then like compiles whatever the Dreamweaver format is into an HTML page. And I might like, my engine might actually be Neopets. Like I might feed my HTML into Neopets and now it's a Neopets web page. Things like processing, you've got specifications, controlled by processing and the processing IDE and the processing engine. So this is like all controlled by one group, even though they're open standards. And then things like regular expressions, which are a very small language. Sorry, I'm running behind, so I'm gonna like scoot through this real fast. Yeah, like there are different places that regular expressions are. And in fact, because regular expressions are so common, people have made engines in every other language. So every other language embeds a little tiny engine for regular expressions. So yeah, what's a language? It looks kind of like this. There's a bunch of stuff. And who's in control of all of this? Like maybe the original source author, maybe a bunch of corporations, maybe social networks, maybe volunteers, maybe software. It's made out of a whole bunch of stuff because in fact, it's an ecosystem of connected components. So a language is all this stuff. So now you've had my 5-minute Very Wrong Programming Languages certificate course. Feel free to print out this certificate and hand it to your boss. But now we're going to talk about how to make all that polite in my last few minutes. So yeah, languages have formal properties. This is one of those things that if you ask a programming language person, they'll get very excited to tell you all the formal properties of languages. Most of that is important that people do. It's not important so much that we do it right now. They also have a lot of informal properties too, like, is this a good language? Do I like this language? Does this language play well with others? It's hard to prove things about that though. So things that you might want to say are things like, this language is easy to write. I remember what my program does after I've written it. I can use this language in lots of strange places. Like if you learn Lua, that works in both, I believe it was originally made for Brazilian power plants, but it's also in Roblox. So you can use Lua in a lot of weird places. This language can run on my machine. That may seem obvious, but if you've only got like a bad cell phone, that might not be true. So here's the Compton completeness theorem, which is like Turing completeness, only completely unprovable. So a first-time user can construct an expressively significant program in an hour using only the computing device they had on hand and connect it to a service or a platform that has social meaning to them. It's important that Tracery itself is not Compton complete. However, Tracery with Artbot.Club or the Bright Spiral editor and with Twitter, and with cheatbots done quick, all those as an ecosystem are Compton complete. So yeah, there's programming languages and then the way that we write programs. A language outside of its normal environment isn't the same language, so we always have to consider the environment. So yeah, a programming language, and importantly, its ecosystem, can be more or less polite. I'm going to quickly tell you about a couple of properties of polite ecosystems, things to get you towards Compton completeness, or just to have a language that people like to pick up. So the first one is, and there's lots more about this in my dissertation if you like to read lots of stuff. So the first one is scaffolding. Like, what does it mean to have a scaffolded language? Often if you start a language, you might open up, say, the Vi editor, and like there's nothing telling you what to do. You don't know what you're supposed to do. You don't know if you're doing something wrong. You don't even know what all the controls are. So scaffolding can be things like, showing you all the parts that you have available, but also things like code completion or code coloring. So it's like, you've typed a line and it auto indents, so you know that that line was actually right. There are things called structure editors, which are really interesting. And these are things that are so scaffolded, like Scratch, that you literally can't get an error. So you cannot, in fact, make a Scratch program that doesn't compile, because it's not only do you only have access to the pieces that will work, those only snap together in ways that will work. And so it's a really great entry level for people who don't want to deal with errors right now. Maybe Scratch programmers will deal with errors later. That's not the problem right now. They're just going to make like little Princess Elsa do a cool snowflake thing. Tracery, I've made a bunch of Tracery editors, but I also want to move on to unfoldable. So an unfoldable language, you might recognize as one that, like, if you've ever worked in HTML, you know that you can say, you can just type plain text, this is my web page. But you can also say, like, this is my bold web page, this is my bold href web page. You can imagine that each one of these unfoldings maybe takes you 5 minutes to learn, or maybe it takes you years to learn. Like, by the time you get to the one at the bottom, like, you might actually be getting fairly involved with HTML. Tracery as well works like this, where a lot of people just write the little hashtag syntax. But in Tracery 2, I'm getting like that fourth line there, like really overly complicated syntax that probably no one will ever write. And this is actually a pattern we see in a lot of idle games, where something like Candy Box, you start off with almost no UI, and then by the end you get a massive UI that nobody actually wants to look at first. Caves of Cud, for example, is not currently very unfolded. Little languages can squish in anywhere. If you have a spot, this language can scooch in there and do something of use. These are languages that can squeak into interesting places. This is actually, of all of these, is the one that comes out of computer science, where there's an article from the 80s describing like what little languages are. But these are things like, how much do you have to install? Do you need like a container? What the hell is a container? Do you need a particular Python version? Do you have dependencies? Can you port this? So we've actually used Tracery, the very base version of Tracery, as a thing that students can learn to port to C, which is an awful language, as an introduction assignment. So like Tracery is extremely portable. Can you call it asynchronously? If you're on the web, maybe you actually have to call this asynchronously. Can you run user-provided code safely? Tracery mostly is safe. Cheatbots Done Quick relies on that. Unfortunately, this is something that somebody made where it turns out that SVG code, so if you have an SVG Tracery bot, you can in fact get it to load all sorts of exciting garbage directly from the internet, because SVG is unsecure. So yeah, safety lights are for dudes. Safety works sometimes. So yeah, in the last 5 minutes, I just want to quickly go over Tracery Chancery's journey to modularity. So it started off as one big JavaScript file that kind of did all the language stuff in one. And then very quickly, I moved to something where there is a section of Tracery that parsed stuff. So it parsed the Tracery syntax. The code was a JSON file, which was great. I gave a talk on how much I like JSON. I broke things out into an engine. So George Buckingham could use it to make cheatbots done quick. So an engine is basically just like you run the Tracery grammar and you get some grammar stuff out of it. I made a whole bunch of tools, some of which needed a compiling step and some of which didn't, to tell you like what the heck your grammar is doing. And most of those were never actually that useful, but I got some good papers published out of them. And then I did a whole bunch more parsing, and I wrote these things at the bottom, which are called, I don't know if you can see my mouse, these are called railroad diagrams. These are ways to very explicitly model what your program's syntax is. So this is like getting towards a specification. I've long ago promised a Tracery specification and then completely not done that because I keep like iterating on these overly complicated diagrams. I did a bunch of cool parsing up in this corner here. I, in fact, did some cool compiler visualizations of like when the Tracery grammar is compiling and when it's running, this is what's going on. And then I tried to write a specification-based parser, and that took a really long time, and I'm not sure if it even worked. But that was something where like you can feed it in your specification of what your Tracery like language does. This is when I got into more languages. It was like, well, why should I write a tool for Tracery when I could write a tool for all theoretical Tracery like languages that I'm making? And so these are things where like I specify the specification and then it outputs generative data. So this is generating programs in a recently generated language, which then I can automatically create an editor for. And so this was all way overly complicated and probably not that useful. And so I actually changed direction after this. And then I did actually a whole bunch more parsing and some more parsing. And then really I just did too much parsing because parsing visualizations are really pretty in HTML. But like I've gotten to a place where I'm happy and I need to stop writing more parsers. So yeah, you can combine all these things into one web page. So this is Artbot Club, which is the site that I'm currently working on to make a like nice non-Twitter hosting place for interesting bots that people can like share bots. You can in fact go to this and you can see I've got like my little parser in the middle, which is telling you how stuff is parsed into, and you've got like a little IDE on either side. And it's also got some like browsing tools, so you can like browse other people's stuff and edit, and you can edit examples. It's got a lot of like pretty cool stuff going on. And then Chancery is something that I've been working on recently, which is a chatbot making language. Here you can see the IDE that I originally published while I was at Google. So it was open sourced by Google while I was working at Google for the Google Assistant. And you can see it's got like a little simulator. It's got a cool diagram of all this, like the state map and how you're moving around the state map. And then it's got some other interesting visualization stuff. So this is, again, a language IDE all smushed together. And when I shipped it at Google, it was too smushed together for anybody to pull stuff out and say, like, I just want the simulator. I just want the engine. So now I've broken it into further sections that now you can get the engine. So you can like write your own weird little engine stuff where it's like simulates a chat. There's cool things that you can sort of plug in. And again, this is like all talk to me after this after the chat, because like a lot of this stuff is free as in mattress. So there's like free as in beer, free as in speech, free as in mattress. Like, yes, you can now download this and play with it, and you will probably never get this thing working because it's all like documented inside of my head. But you can write things that like have attachments to, you know, not only is somebody chatting, but they're also like posting images. And yeah, just as a final last thing, there's a as a case study, I also use this to do a contract gig for a Swedish ambient album / mid-century poetry LARP, where there's a mid-century poem called Aniara that some Swedish ambient musicians made an album about, and they wanted to run a LARP and also have a character. And so I made a puppetable virtual character that hooks into Chancery. And I'll talk about how it does that in just a moment. You can go here, you can go to mima.chat. But yeah, this is a puppetable virtual character using Chancery, which also uses Tracery to generate text. And why does this work? And I'll just skip over that. Because blackboards are a concept from AI, which basically means a space that every program can read from and write to in their own way. And yeah,
I'm ominously, just because we're running short on time. Sorry, Kate.
No worries. Yeah, so you can also hook up your MIDI controller to a blackboard and have that control the puppetable character, who is also being controlled by Chancery at the same time. And yeah, that is my slide. So cool. Sorry for running a little long. You can totally go to artbot.club, and if you really want to, I'm giving a symposium exercise where we're all going to program a group Tracery thing together in Artbot Club next Tuesday. So if you want to join that, please do. I think it's free.
That sounds wonderful. Thank you so much. And yeah, I hope that we can get a bunch of those links and tweet them out because holy moly, that's a lot of great stuff. Yeah, just wonderful as always. There's unfortunately quite a few questions and no time to get to them. The only super fast question.
I will be in chat and I will talk very rapidly on a keyboard.
All right, that's good. People have questions about Neopet guilds. There's a lot of love for Neopets and many questions. So thank you so much, Kate.
All right, thank you.